This one is सबसे latest वाला, ठीक है? One that just happened, ठीक है? That's this one, ठीक है? February March 2023. एक सेकेंड और देना मुझे. So starting with the first question. ठीक है, this one, starting with the first question. There's an electronegativity table that's provided, and you're being asked about the electronegativity table. You're being asked, use the information to answer the following. Define how do you define electronegativity? That is, it's the tendency for an atom to gain electrons, right? To gain a shared pair or to attract a shared pair of electrons, or simply to attract electrons. Okay, that's what electronegativity is. O and S are in group 16. Explain the difference in the Pauling electronegativity values of O and S. So O and S, periodic table mein na, oxygen is like this is group 16. So O is over here and S is over here. So remember, down the group electronegativity decreases. Okay, that is shown over here as well. Okay, oxygen, that's more electronegative. Sulfur is actually less electronegative. So explain the difference. The first thing is oxygen is more electronegative compared to sulfur. What could be the reason for that? Why are smaller atoms more electronegative? Smaller atoms are less shielded. They've got a less shielded nuclei.
So they can attract the electron
less shielding.
more strongly.
So that's why there's greater attraction, right? Just 2 marks. So that's it. I mean, one was that to explain the difference. So smaller atom, atomic radius is smaller. So the distance of the outer electron is also less, so that leads to more attraction between the nucleus and valence electrons, or electrons generally. As the next one is LiH is an ionic compound. Draw a dotting cross diagram to show what LiH is. Li is 3 electrons. It's group 1. H is 1 electron. Now H is the non-metal over here. Okay, यहाँ पे ना Pauling scale values के अंदर it's given Li has an electronegativity value of 1. H is way more electronegative compared to that. So he's already told you that it's an ionic compound. So that means Li is the one that's going to lose the outer electrons. Okay, that outer electron is going to be lost. Li will have a charge of +1 and H will gain electrons. So H is going to be -1. Suggest the shape of an H2S molecule. So what's the shape of an H2S molecule?
Bent.
Okay, it is bent. It's S के पास कितने lone pairs होंगे? It's in group 6, right? So it's making 2 bonds. So if it's in group 6 and it's making 2 bonds, that means 4 electrons are left. 2 lone pairs. But the lone pairs are not counted in the shape. It would have been tetrahedral if there was something attached on this side, but there's nothing attached. So it is bent. Angle kya hota? What's the angle in SiH? Well, if it had been tetrahedral, it would have been 109.5. But since it has 2 lone pairs,
104.
104 degrees. 104.5 to be specific. As the next one, write an equation to show the first ionization energy of H. So plus 8 say you're removing electrons, 1 electron, right? And always remember it's going to be a gaseous atom. So you'll be removing electrons from a gaseous atom. Explain why there's no information in the table 1.1 for the second ionization energy of H. Now that's a very stupid question because obviously there's no second electron. H only has 1 electron. Okay, that's the answer. Give the full electronic configuration of sulfur 2 plus. Sulfur is 16. 2 plus means it's 14 now actually. So 1s2, 2s2, 2p6, 3s2, that's 12, and 3p2.
2.
Okay, now it's going to have 14 electrons. That's a CO2 and SO2 are acidic, right? An equation to show the reaction of SO2 with H2O. What is going to be formed? क्या होगा SO2 plus H2O? What is it?
SO plus O2.
नहीं बस H2SO3 acid बन जाएगा. These are all SO3. It will just add them up. H2SO3 will be formed. Remember, SO3 forms sulfuric acid. NO2 will form nitric acid. Carbon dioxide will form carbonic acid. Okay, so now he's asking for an equation for the reaction of SO2 with NOH. Now, SO2 with NOH, imagine this as a reaction of H2SO3 with NOH. So the salt, it's an acid-base reaction. So the salt that's going to be produced is going to be Na2SO3, Na plus 1 SO3 minus 2, plus water. Okay, water is going to be produced as a byproduct. And always remember that you'll be very often asked about inorganic versus inorganic. Just a second. About these acidic oxides. Yeah. So about these acidic oxides, always remember when you have to make equations for these acidic oxides. So think of them as not SO2, but think of them as, think of SO2 as H2SO3. Think of SO3 as H2SO4. The sodium sulfate banega. If you have this other one, if you have this other thing, just a second. If you have P4O10, think of it as phosphoric acid. P4O6, think of it as phosphorus acid. Okay, you open the reactions with water already given. P4O6 will form HCPO3, P4O10 will form HCPO4. So when you're writing equations for P4O10, so think of them as not as P4O10, think of it as HCPO4. So equation figure out karna, that would be kind of easy. So just as an example, like if they tell you, okay, we write an equation of P4O10 with NaOH. So don't think of it as P4O10, think of it as phosphoric acid. Now it would make a lot more sense. It's going to be sodium phosphate and H2O. And the same is happening over here as well. He's asking to write an equation for the reaction of CO2. So he's asking for an equation of CO2 with NaOH. So Mr. CO2 को क्या सोच के लिखना है? What do you think of? What would you write CO2 as? Like if it reacts with water, what acid is formed? The carbon dioxide में water add करो, what acid is formed? It's going to be
carbonic acid.
It's going to be carbonic acid, right? So think of this reaction as a reaction between carbonic acid and NaOH. So it's going to form sodium carbonate and water, right? So, obviously you don't write H2CO3, but
Sir,
Haji.
the question says MgOH2.
Say एक second. पहले तो इसकी डायरेक्शन के साथ चेंज करना एक सेकंड. ठीक है, चलो ठीक है, चेंज इट टू एक सेकंड. if it's MgOH2, then just change the थोड़ा सा ही change करना है, change it to Mg. अच्छा, change it to MgOH2. And यहाँ पे ना it's going to be MgCO3 then. It's going to be MgCO3 and water. So anyways, but like, remember this point, always remember this point that SO3, SO2, P4O6, P4O10, if you were to write an equation, don't think of them as this thing, think of them as acids. As the next part. And the same applies to NO2. Like if they ask you to write an equation for NO2 with any base like NaOH, don't think of it as NO2, think of it as nitric acid. Then it would be sodium nitrate and water that's going to be produced. I say anyways, so complete a table by placing a tick to show that the compounds have molecules with an overall dipole. So this thing, carbon dioxide, will it have an overall dipole? And what is the shape of carbon dioxide?
180, and I think no dipoles because they cancel out.
Cancel out. Okay. Both oxidants will be pulling electrons and they will get cancelled out. So no dipoles over here. As a SO2, what is the shape of SO2?
Um, 117 maybe.
Okay, SO2 is that it's a double bond, but S is in group 6, so it's making 4 bonds. So if a group 6 valence electrons and it makes 4 bonds, so that means there are 2 electrons left. So it's actually around 120 degrees. It's fan shaped, but it's basically bent. The oxidants are the more electronegative atoms, so the dipoles are not cancelling out. The oxidants are pulling the electrons downwards. So there is going to be a dipole in this case. Acha, tick lagana tha, not. Acha, CS2, will there be, what is the shape of C with 2s atoms? Will be linear hoga na? It's going to be linear. Why? Because carbon has no lone pairs. So one bond would be on the right side, one bond would be on the left side. So it's going to be 180 degrees. Sulfur is sulfur the more electronegative one, by the way? Probably it is. Yahan pe it might be given over here. Sulfur is more electronegative compared to carbon. So over here, there's not going to be a dipole. It's going to get cancelled out.
Sir, carbon के ऊपर lone pair क्यों नहीं होता?
Okay, carbon is in group 4, right?
जी.
So it's got 4 valence electrons.
Okay,
2 electrons are shared over
here.
Use up ho gaya na, 2 electrons shared, so there's nothing left. C double bond over here, double bond S, so there is no lone pair. It's going to be linear, but oxygen is the more electronegative of all the atoms over here. So there's going to be a dipole. This side will be negative and this side will be positive. So you will have a dipole in this case. Okay? Is this clear?
Yes, sir.
So in the next one, there's a gas at 150 degrees centigrade, 103 kilopascals, all of the compounds listed in table 1.2. Which one is, this is table 1.2. Are gases. So all of them are gases. Under these conditions, 0.84 grams of one of the compounds occupies a volume of 127 cm3. Use this information to calculate the amount of the compound, hence identify the compound. So it's a PV is equal to nRT question. N is moles, so moles is mass over MR. The pressure has to be in pascals, so that's 103 times 10 power 3 pascals. The volume must be in meter cube, so it's 127 times 10 to the power minus 6. Okay, if you want to convert cm cube to meter cube, that's multiplied by 10 power minus 6. The mass is already given, that's 0.284 grams divided by the MR, which we don't know. R is 8.31. And the temperature is 150 centigrade, which should be in Kelvins. What is 150 in Kelvins?
$423.15.
So was this find the MR now?
It's a 76.3.
So it's coming out to be
70,
70.
a 76.3.
So who is it? 76.3. Definitely carbon dioxide is 44. This is 64. This is 32 plus 32 plus 12. So you know, is it 12? 32 plus 32, that's this. It's going to be this thing, I think. See? 32.1 plus
Yes, sir. 36. Sorry, 76.
Okay. So we've identified the compound. Next question. You have to show, draw a label diagram to show the bonding and structure of a metal. Just show it, right? So, and a group 2 metal, right? So what is metallic bonding? It's a bunch of positive ions. Here, draw a bunch of positive ions. And since it's group 2, so they'll all be positive 2 ions. And in a sea of describe you just have to draw a label diagram, right? So you don't have to write anything, no explanation needed for this. Explanation agar hoti na, what you would have written is it's a regular arrangement of positive metal ions. It's a lattice of positive metal ions in a sea of free moving electrons. So there's going to be a sea of free moving mobile electrons. As I explain why Mg has a higher electrical conductivity than Na.
Because it has more delocalized electrons.
Okay, Mg loses 2 electrons while Na just loses. So it's got more delocalized electrons. It's got more valence electrons. So that's why it loses more electrons. What's the equation of, now all metals in group 2, they react with water. Mg with cold water is a very
Magnesium
slow
hydroxide with H2 gas.
magnesium hydroxide, and it's going to be a very slow reaction, Reactivity in group 2 increases down the group. So next part is identify a single reagent that can be used to distinguish separate samples of dilute magnesium nitrate and barium nitrate. Now this is a lab test. So how do you identify barium ions if you remember what the lab tests are? What's the difference between magnesium? Uske liye ye yaad rakhna padega, this one, these lab tests. 1 second. But barium is easy. How do you identify barium, by the way? The barium test is kind of.
Sir, सिर्फ इतना पता है cream color आता है उसका. Ag ions को I think डालकर.
एक से मैं लैब टेस्ट यहाँ पे होंगे. हाँ, ये टेस्ट आ गया. अच्छा, magnesium का जो test है, that's you get a magnesium ions can be identified using NaOH and NH3. You get a white insoluble precipitate, and you got a white insoluble precipitate with NH3 as well. Okay, that's magnesium. But that's not one reagent. He was asking for this is 2 reagents. He was asking for just one. Identifying barium is the easiest because barium with sulfate ions, they give a white precipitate with barium ions. So all you have to do is you just add sulfuric acid and you'll get a white precipitate. That's what's going to happen. Okay? Is this clear?
Sir, ये सारे याद करने हैं?
हाँ, मतलब like Cl-1, Br-1, I-1. This often comes in organic chemistry. You already know that carbonate, they react with acids to produce carbon dioxide. Yeah, that is already known. The test for nitrate, I guess you have to, I mean, these ones you have to remember. Sulfate is, this was in O-levels as well, okay? I mean, the test for gases as well. How do you identify carbon dioxide? It turns lime water milky. How do you identify ammonia gas? Oxygen gas relights a glowing flame. I mean, so these are like really basic tests. So they're going to assume that you know all of them.
Okay, sir.
So identify a single reagent. So I guess sulfuric acid or any sulfate, anything that's containing explanation. What's going to happen? That barium ions will react with sulfate ions to form an insoluble precipitate, and that will give you a white precipitate. That's the next part. Describe what is observed when SRI2 is reacted with concentrated sulfuric acid. So this is again a typical group 17 question. It's I-1, SRI2 contains I-1, and it's being reacted with concentrated sulfuric acid. Now, this is a typical group 17 question. What happens in group 17 down the group? That the ions, they become good reducing agent. Which is group 17, I think this one. अच्छा, so यहाँ पे ना होता ही है कि you've got F-1, Cl-1, Br-1, and I-1. The bigger the ion, the easier it is for it to lose electrons. So I-1 loses electrons very easily. It gets oxidized very easily. It forms iodine. I-1 is a very good reducing agent. It's a very powerful reducing agent. Now, there's a typical reaction of halide ions with concentrated sulfuric acid. When NaCl reacts with it, you don't get a redox reaction. Cl-1 does not like to lose electrons. So you only get displacement. That the H+1 ions and the Cl ions from the NaCl, they combine to form HCl gas, which escapes the solution, and you get a white fume of HCl gas. Lekin down the group kya hota hai? Br-1 and I-1, they become really good reducing agents. They really like to lose electrons. When I-1 reacts with sulfuric acid, you do get a displacement, you get HI, but I-1 really likes to lose electrons. It turns into I2, and sulfur has to gain electrons. Sulfur gets reduced to either sulfur or H2S or all these other compounds. So describe what is observed. So what is observed is that the sulfur is going to get reduced to sulfur. That's going to be a yellow solid. So yellow solid would be produced. The I-1 will turn into I2. So that's your blue-black solid. Or if it vaporizes, it's going to be a purple vapor. Some H2S might also be formed. So it's got the smell of rotten eggs. That's also written in the notes. Compare. H2S is rotten eggs. Iodine is formed, which is purple. So this is the reaction that's happening. I-1 is a very good reducing agent, turns into I2 and reduces the sulfur to sulfur or H2S or all these other compounds. As the next one. ये clear है ना ये चीज?
Yes, sir.
And remember,
Yes.
question हर paper में आएगा, ठीक है? It's going to come in your paper as well. Specifically this one. ठीक है? This comes in every paper. This part, that Br-1 and I-1 are really good reducing agents. They like to lose electrons. So when you react them with sulfuric acid, they end up starting a redox reaction over there. NaCl does not do a redox reaction. Cl-1 does not like to lose electrons. As the next one, compound X is an anhydrous group 2 bromide, is dissolved in water and titrated against silver nitrate. So there's a bromide which is titrated with silver nitrate. So silver ion. So basically this is the reaction. You'll get a precipitate Ag plus 1 and Br minus 1 will combine to form. It will combine to form AgBr. A solution containing this is X. You don't know what the group 2 bromide is. So the solution containing 0.25 grams of X requires this much silver nitrate. So how many moles of silver nitrate are we adding?
1.6825 times 10 to the power minus 3.
1.6825 into 10 to the power minus 3, right?
Yeah.
अच्छा इतना इसमें ना वो डाल दिए silver ions. So the amount of Br ions will be exactly the same, right? It's 1:1. So that's going to be 1.68 times 10 to the power minus 3 moles. So Br ions will be exactly the same. And where are all the Br ions coming from? They're coming from a group 2 bromide, right? A group 2 bromide will have a charge of +2, right? A group 2. So the molecule will have 2 Brs, right? So when it ionizes in water, it's going to produce 2 Br ions. Like one molecule will produce how much? 2 Br ions because it's a group 2 bromide, right? So अगर इसके moles 1.68 times 10 to the power minus 3 है, the moles of the other substance will be half of that. What is half of that?
8.41 into 10 raised to power minus 4.
And you know the mass as well, which is 0.250 grams. So you can find the MR, which is, what is MR? It's mass divided by 8.41 times 10 to the power minus 4 moles, right?
297.17.
And so you have to identify X. So इसके अंदर दो bromines हो गए ना? There are 2 bromines, right? What is bromine? That's one. I think that's 116 total. Remove 160 from this. So what is the
137.
137? 137 is, I think it's barium.
Yes, sir.
ठीक है, so that's barium. अच्छा, लेकिन इसमें ये clear है कि what we did was that you had silver ions reacting with bromide ions, so they were reacting in the same ratio, so you figured that out. And then told us that this bromide is a group 2 bromide. So a group 2 bromide, one molecule will have 2 bromide ions, right? So based on that, the moles of the group 2 bromide will be half of that. And here was Hanta. You had the mass, you had the moles, and you were able to figure out the MR. And taking bromide out, you found out what X is. Okay. So next question number 3. What's an addition reaction? Well, it's a literal definition. What's an addition reaction? It's a reaction in which what happens? 2 or more compounds molecules, they add up to form a single molecule. State the type of structural isomer shown by A and B. So what type of structural isomerism is this?
It's positional. A positional.
is it positional? It's you're not changing the position, I guess. You're changing the chain in this case. This one looks more to, I mean, it's a carbon chain. 1 second, 1, 2, 3, and then you've got an aldehyde group. It is actually positional. The chain.
सर इसी की चेन भी अब बनाकर दिखाएं कि अगर ये चेन होती तो क्या डिफरेंस होता?
3 carbon atom, you can't change the chain.
Okay.
उससे बस aldehyde functional group, he's changed the position, so it is positional. Name A. What's A? What is the name of A?
A propanol.
It's 4 carbon atoms. 1, 2, 3.
Okay.
There's a 4th one as well, so it's butanol.
Butanol.
Then you have complete the reaction of propene with 1,1 mixture. Complete the reaction of propene with a 1,1 mixture of CO and H2. That means what does 1,1 mixture mean? It means that they are probably in the same quantity. It produces A and B only. So the product mixture contains 96% of A. And for calculate the mass, so what's happening? Calculate the mass of A produced in this reaction. So here's not really sure what he means by this, but let's try. Okay, there's propene, which is C3H6. ये जो पहला वाला है, ठीक है? This is propene. And it reacts with a 1,1 mixture. I don't know what that is, but I'm just assuming that means that they'll be in the same ratio. And it produces A and B. So A is C4H8O, right? And B is also the same. It's an isomer, so it has the same formula. So you get A and B. And he says that 96% of the product is actually A. Calculate the mass of A produced in this reaction when 5 times 10 power 3 kg of propene is used. पहले ये देखो कि it is balanced, right? I mean, this is, if you add this up, this is actually C4H8O. So it's 1:1, like this entire thing. Let me just get rid of this. Both of them have the same formula. So the only difference is that they're isomers. So it's either going to be A or B. 96% is A and 4% is B. This equation is balanced. It's 1:1. I think everything is 1:1. So if it's 1:1, that makes things easy. So all you have to do now is, so you got 5 times 10 power, how much? 3 kg. So figure out what the moles are. Mass divided by MR propene is, I think, C3, that's 12 into 3, that's 36 plus 6, 42. Okay, it should not be in kgs, it should be in grams. So how many moles do we have?
119 into 10 raised to power 3.
And this product is going to have the same moles. It's 1:1. Everything is 1:1. So whatever moles you got over there.
सर आपने इसको ग्राम्स में क्यों कन्वर्ट किया है?
Well, moles का जो formula, that's in grams. Molar mass is in grams.
Okay.
MRs जो होती हैं, they're in grams. So you got 100, so it's 1:1. So you're going to get this much. And then he's saying, okay, find the mass of A. So he's saying that 96% of the C4H8O that's produced, I mean, both of them are C4H8O, but he's saying 96% of it has this formula, structural formula. So you're going to get a total of these many moles. 96% of this, figure out what 96% of this is. That's going to be A.
114.28 into 10 raised to power 3.
And then multiplied by the MR to find the mass. So what's the MR? 12 into 4, that's 48. 48 plus 8, that's 56. Plus 16. So 72 is the MR. तो आपके पास mass आ जाएगी, ठीक है? What is the mass that you're getting?
8.228 into 10 raised to power 6.
Or 10 power 3 kgs, it's in kgs, so convert that back into kgs. ठीक है, clear है?
Yes, sir.
अच्छा, अगला part ये कि A and B are typical aliphatic aldehydes, ठीक है? Remember, aliphatic is all the organic compounds that you've studied, they're all aliphatic, ठीक है? As opposed to aromatic. Aromatic में ना benzene आ जाता है, which is not in your course. Aromatic is this thing. A2 के अंदर है aromatic. So just don't get confused with aliphatic. Aliphatic is your normal organic compounds. They're all aliphatic. A undergoes nucleophilic addition reaction with a mixture of HCN and KCN forming compound C. Complete a diagram. So he's asking for the mechanism of nucleophilic addition with HCN. Okay, so what is this reaction? वो बस notes के अंदर the mechanism. Nucleophilic addition is कहाँ पे revision chart. The CN minus one is going to come in and it's going to attack the carbon that's positive. When you have an aldehyde or a ketone, the carbon over here is partially positive. So the Cn minus one is going to get attracted to this carbon. It's going to bond with this carbon. The double bond electrons are going to get repelled. So HCN में जो H है, that's going to come and bond with the O at the top. So that is what the reaction that's going to happen. So draw everything exactly the same. Everything has to be, you got a carbon positive, you've got a partial negative oxygen, you've got a Cn minus one that's coming in with its lone pairs, show the lone pairs. Then what will happen is that the Cn will bond with the carbon. There is C3H7 on this side. The oxygen will be repelled, and in the next step, the H from the HCN will join and it will form OH. The table shows information about 3 experiments involving B. I said, remember about mechanisms. Again, I repeat. Everything has to be the 3-4 mechanisms. Everything, every arrow, every partial positive, partial negative charge. The lone pairs have to be on the right atom. If it's Cn minus one, the lone pairs are on carbon. If it's the intermediate, the oxygen will have the lone pairs. So everything has to be drawn exactly the same way. Now shows information about 3 experiments involving B. B is the other one. First thing, solution turns from orange to green. ये किसका color change होता है when it? Which solution always turns from orange to green?
Dichromate, sir.
Oh, math.
Dichromate, sir.
Yeah, that's dichromate. It's K2Cr2O7, right? Acidified. So he reacts B with, where's B? B is an aldehyde. So what happens to an aldehyde if you oxidize it? If you react it with, what happens to it? It turns into a carboxylic acid. The aldehyde, if you react it with K2Cr2O7, you're going to turn it into a carboxylic acid. So this thing will turn into a carboxylic acid. It will become COOH. A silver mirror forms on the sides. So when you get a silver mirror, what's the reagent?
Tollens.
Okay, that's Tollens. Tollens gives you a black breastplate and a silver mirror. Will be oxidation. Aldehyde gets oxidized to a. So it's an alternative reagent that could be used for K2 instead of K2Cr2O7. You could use Tollens. फिर आखिरी bromination. Will it react with bromination? Do aldehydes react with bromine?
No.
They don't. Bromination जो होती है वो alkenes की होती है. They don't react. So they would have reacted if it had been UV light as well, then the carbon chain would be substitute. I mean, the hydrogens would get substituted by bromine, but not in this case. So you're not probably no reaction.
सर अगर उसमें यूवी लाइट होती वो तो एल्केन का हेलोजन एल्केन नहीं बनता था.
नहीं वो होता है कि any carbon chain, it's not limited to free radical substitution, is not limited to alkanes. Any carbon chain, whatever it is, even if it's an aldehyde, the H's over here will be substituted by bromine. Eventually.
If UV light is given.
हाँ वो सिर्फ UV light के अंदर, because radicals will be produced in UV light and they'll start removing H atoms and start displacing H atoms from the carbon chain. So free radical substitution, remember, is not limited to alkanes. It could happen to any molecule. अच्छा वो कह रहे हैं C4H8 O is oxidized by B is oxidized by acidified potassium manganate 7. Complete the equation for the reaction. Use O as the reagent. One atom of oxygen. So O as the reagent. So we already discussed what will happen to it. It was 3 carbon chains and there was an aldehyde at the top. So I told you that it will turn into a carboxylic acid. It will turn into a carboxylic acid. 3 H's, this one will have 1 H. This one will have 3 H's. So see what I draw and remember it was like this. This thing was an aldehyde. And remember, aldehydes always turn into carboxylic acids. And when you're trying to balance an equation with oxygen, this is a typical oxidation reaction. So when you try to balance an equation with oxygen, if it's not getting balanced, add a water over here. So kitne oxygens? You're getting 2 oxygens, so probably. And how many hydrogens do you have? You've got 8. Now we've got 3 and 3, 6, 7, and 8. So मेरे ख्याल से this equation on its own is balanced anyways. Balanced ही है मेरे ख्याल से. ठीक है, clear है?
Yes, sir.
Yes, sir.
अगर नहीं हो रही होती ना, you could have added a water molecule to either side just to balance it. Now,
आप किसी भी कार्बन चेन के अंदर एडिशन कर सकते हैं वाटर की, यही स्पेसिफिक है.
नहीं ये तो सिंपल वो एक टिपिकल एल्डिहाइड है जो टर्न हो रहा है किसमें, इट्स टर्निंग इनटू कार्बोक्सिलिक एसिड, राइट?
ओके.
तो लेकिन वो कोई भी ऑक्सीडेशन रिएक्शन है ना, इफ दे टेल यू कि द ऑक्साइजिंग एजेंट यूज O as an oxidizing agent, and if your equation is not getting balanced, so you can add water to this side or that side just to balance out the oxygen, balance out the equation. ठीक है? As a circle, any chiral center that which carbons are chiral over here?
First one, the one with OH.
The one. Yeah, the first one, and that's it. Yeah, that's the only one, right? So that's the only one. The molecular formula of alkane. What it is, when propene reacts with CO and an excess of H2, and alkane and a mixture of alcohols are formed instead. The alcohols are isomers of each other, suggests the molecular formula of the alkane and the alcohols that are formed under these conditions. So propene, I have to make an equation. Propene reacts with CO and an excess of H2. So he's saying that an alkane and a mixture of alcohols are formed instead. And the alcohols are isomers of each other. So what is the molecular formula of the alkane and what is the molecular formula of the alkene? Now, assuming it's, is this 1:1 or not? So he's saying that पिछली वाली equation के साथ ही कर लेते हैं. Where's the previous equation? So I'm assuming it's, I think he's still talking about 1:1. So the only difference is he's saying that an alkane and a mixture of alcohols are produced. So kahan se isne out of the blue isliye, where did you get this? Just a second. I said the previous parts have nothing to do with this. So I guess figure this out yourself. What, based on this, what is the alkane that's going to be formed? Well, agar hydrogen react karega iske sath, hydrogenation would happen, right? Like you got
So C6H8.
C3H8.
Sorry, C3H8. Yeah.
Yeah, that's one C3H8. That's the possible alkane, right? So what could be the alcohol that could be formed? Agar isme CO add karo, you would get a 4 carbon atom. What's a 4 carbon atom alcohol? It's probably going to be, like if you have a 4 carbon atom alcohol, so that's 10 hydrogens, right? So you'll get C4H10 and O. So what you have is C3H6, and you add carbon to it and oxygen to it, and oxygen to add hona another, because then it's going to form an alcohol. So it's going to become a 4 carbon atom alcohol. So C4H8O, right? H10O, sorry.
Sir, 3 carbon alcohol नहीं बन सका.
नहीं, क्योंकि alcohol कब बनेगा जब oxygen add होगा, right?
जी.
So the oxygen is with the carbon, right?
Okay.
बस ये मैं कह रहा हूँ, it's a very, this part is very random. They really didn't give you any information. हाँ जी.
Well, we only have like 8 hydrogen equation in the equation initially.
Nee, we had how many hydrogen?
2 and then 6.
Yeah, we had 2 and 6, but he said that over here he's not saying that it's 1:1. What he's saying is that there's an excess of H2, so you could have 2 H2s or you could have 3 H2s, right? Is that clear?
Yes, sir.
So I'm just going with the fact that he's saying that an alkane is formed. So I've got an alkene. If you hydrogenate it, it will form an alkane. So I'm just, my guess is C3H8 would be the alkane, right? Is that clear?
Yes, sir.
And then he says that alcohols are formed. So if you're forming alcohols, then the carbon monoxide probably got added over here. So you'll have a 4 carbon atom alcohol. So you'll have a 4 carbon atom alcohol. Is that clear?
Yes, sir.
Yes, sir.
अच्छा अगला part क्या है? अगला part है कि the reaction of ethene with 1,1 mixture of CO, again it's the same, CO and H2 is shown. So they've finally shown you a reaction, right? An atmospheric pressure cobalt-based catalyst is used in the reaction. State and affect the why do you use? I mean, basically he's asking why do you use a catalyst?
To reduce the activation energy.
ठीक है. So what does that do?
To quick
Speed up the reaction.
speed up the reaction.
Speeds up the reaction, and you could write a bit more detail, like if you have if the activation energy is reduced, what do you get? You get more successful collisions or more effective, or the proportion of successful collisions increase, more successful collisions. That's the next one. Explain why the yield of this thing increases when the overall pressure of the reaction mixture is increased. So coming back to this, it's an equilibrium reaction. Why would the yield increase if you increase pressure?
Because maybe it will cause a forward reaction to take place.
Okay, so higher pressure will favor which reaction?
Forward. Less
लेकिन
gas.
उसमें आप
Okay.
लिखोगे less gas mode side is favored.
Mhm.
And that's forward, ठीक है? That's why you're going to get forward reaction is going to be favored, or forward reaction will be relatively faster. Now use the information in the table. So you have to find the enthalpy of this reaction. So if you know the enthalpy change of formations of C2H4, which is 52, the enthalpy of formation of CO is minus 111. The enthalpy of formation of this thing is minus 187. The enthalpy of formation of H2 is 0 because elements it's 0. So if you know the enthalpy of formation of all the reactants and products, what's the formula?
Product minus reactant.
Okay, so it's product enthalpy of formation minus the formations of the reactants. So it's going to be minus 187 minus the reactants, which is 52, minus 111. So what are we getting?
Minus 2 to 8.
Kitna minus?
2 to 8.
Sir, is it minus 1 to 8, sir?
1 to 8. Sign ka khayal rakho, minus 1 to 8.
Oh, yeah.
Okay, and next one, the reaction mixture is cooled to collect aldehyde as a liquid. Identify all types of van der Waals forces that are present between molecules of this thing, propanol. So kaun si what?
OH, so hydrogen bond.
He doesn't have an OH. It's
CHO, okay.
CHO jo hota hai na, usme the O and H are not together.
Hmm.
So what intermolecular forces do you have? And one thing is you have a permanent dipole. And then you always have the instantaneous dipole induced dipoles. Okay, is this clear?
Yes, sir.
Sir, are permanent dipoles parts of van der Waals?
अच्छा यहाँ पे ना van der Waals usually temporary dipole induced dipoles or instantaneous dipoles are referred to as van der Waals forces. But sometimes van der Waals forces are generally used for intermolecular forces.
Oh, okay, sir.
So sometimes van der Waals, the word van der Waals, that's used to describe all types of intermolecular forces.
Okay, sir.
So now show some reactions of compound D. So you, I guess, he's asking for the reagents. How do you go from a halogenoalkane to an alkene?
Concentrated NaOH.
The NaOH hota hai, lekin it's this one. It's
Ethanolic.
concentrated NaOH, but it's ethanolic as well, plus heat.
Mhm.
So the halogenoalkane will turn into an alkene. Okay, so that's the reaction. So NaOH ethanolic plus heat. So then he's asking for you have to draw the addition polymer. So that's easy. It's you've got a double bond between two carbon atoms. There's a carbon on one side, there's a carbon on the other side. So that's 3 H's. There's a 3 H's over here. There's going to be 1 H and there's going to be 1 H. What happens in an addition polymer is that the double bond in the middle becomes a single bond, and the carbons, they start interlinking with the same repeat unit. And then he says, write an equation. E forms when F is heated strongly in Al2O3. So F, that's dehydration. That he's saying that F, if you react it with Al2O3, E gets formed. And he's just asking for an equation. So water gets removed. So this is what? This is F is C4. H kitne? That's 1, 2, 3, 1, 2 over here, 1, 2, 3, and there's going to be 1 over here as well. So that's 10H. So it's going to get dehydrated. It's going to form an alkene, which is C4H8, and it's going to release a water molecule. Okay, the OH and H get removed, and you get a double bond back over here. Okay, is this clear?
Yes, sir.
Yes, sir.
अच्छा फिर ये था कि ये चार्ट के अंदर यहाँ पे it's dehydration, alcohol turning back into an alkene, that's Al2O3 plus heat. Now predict what is observed in reaction number 2. So silver nitrate, you're adding silver nitrate, this bromine. So what kind of precipitate will be formed? Silver and Br, they form AgBr. So what is the color of the precipitate?
Cream, sir.
Okay, that's a cream colored precipitate. AgCl is white, AgI is yellow. Ag and Br, that's a cream colored precipitate. Then he's asking for identify the yellow. So this is the iodoform test, this one. Alkaline iodine, that's the iodoform test, which is this one. Whenever you have a CH3, which is right next to a CHOH, iodoform test is positive for two things. You need a CH3 either next to a carbonyl or either next to CHOH. The CH3 breaks off and forms a CHI3 yellow precipitate. So that's your yellow precipitate in this case. So यहाँ पे ना, this part over here, the CH3 part in the iodoform test will, the molecule will break off over here and it will form a yellow precipitate of CHI3. And the other part will turn into an organic ion. So it's going to look kind of the same. It's 2 H's, 3 H's with this one. And this part will become double bond O, O minus 1. ये H लगा देते हैं. ठीक है, so this carbon over here turns into a salt of the carboxylic acid under alkaline conditions. So yeah.
Yes, sir.
और अब ये है कि state the type of reaction that occurs in reaction 4. So reaction number 4. What is this reaction? Ethanolic KCN. The Br getting substituted by a CN. So what is the reaction called?
Substitution.
Or to be more specific, what type of substitution is this?
Free radical.
Free radical, yeah, that's
Nucleophilic.
Nucleophilic.
इसके SN1 SN2 reactions होते हैं halogenoalkanes. ठीक है, that's the CN-1 is a nucleophile. It's attracted to positive charge and it has a SN1 SN2 mechanisms होते हैं. ठीक है, this one. That halogen, you got a polar carbon atom, so the nucleophile, whether it's CN-1 or OH-1, it gets attracted to it. So it's nucleophilic substitution. So then reaction 5 is similar to reaction of LiH4 with carboxylic acids to form alcohols. So suggest the role of LiH4. That's a reducing agent. That's it. You need to know that LiH4 is a reducing agent. Then he says shows the infrared spectrum of one of the compounds D, E, F, G, H, or G. And you have to use the information to identify which of the compounds. So all the compounds are drawn above. So what is this thing? First thing, there's a strong absorption around. इसमें मैंने क्या कहा था infrared spectrum में? You look for two things first. You always look for C double bond O. Do you have an absorption for C double bond O around the 1600, 1700 range? So in this case, you don't. There's nothing over here. So that indicates that it does not have any serial bond O's. Is that clear?
Yes, sir.
And because of that, a lot of things will get eliminated probably. Well, not a lot of things. Okay. None of them actually have a serial bond O, so nothing gets
Sir,
eliminated.
yeah.
So,
Same thing.
so none of them have serial bond O, so that's fine. Do we have an alcohol? Where do you have the alcohol hydroxy, the alcohol, just alcohol? That absorption happens around the 3200 to 3600 mark. And you have another OH, which is the carboxylic acid OH, which is around 2500. But let's go with the normal alcohol. There's no absorption at the 3200, so it's not an alcohol. There's no OH that belongs to alcohol, so all the OH ones are gone. So I guess this is gone. F is gone. Who else was an alcohol? So none of them were actually alcohols. So no, we're still not able to eliminate a lot of them. So most of them are still candidates. So we've got this absorption at 2200. This one. So have a look at 2200. That must be this one.
Nitrile.
So must it's a nitrile. So there's only one nitrile, which is G. Okay, that's going to be our answer in this case. Is that clear?
Yes, sir.
Yes, sir.
So for the last part, I think there were just 4 questions. Explain. You're just going to explain that this is CN. This is at 2200. Quote the exact value. What's the exact value? The exact value is 2200 to 2250. So it was a nitrile that was present, and you just tell them that. Therefore, it's G. That's the answer.
And sir, 1500 से above हम नहीं देखते क्योंकि वो fingerprint एरिया होता है.
नीचे.
Okay, yes, below हो रहा है.
You don't really get a lot of information.
Okay.
So ठीक है, that's it. ठीक है, this is done. चलिए ठीक है, फिर कल करते हैं, ठीक है.
Allah Hafiz.
Okay, Allah Hafiz.
Good night, sir.